All right, perfect. Okay, so let's take a look here. The question is, how many grams of hydrochloric acid, HCl, do you need to produce 65 grams of lead chloride? Which you should have immediately started with is, what do we already know? And we know this number, 65. So this 65 is related to the lead chloride. So I'm going to start off with what I know. I'm going to start this on the pink side. So this will be the pink side. Thanks, Ame. It's actually blue though. Over here, so we've got lead chloride on the pink side right here. And again, we're starting off with what we know, and it says here that we have grams. So we're specifically starting off with grams, which you are correct. Most of you identified that as the mass. I'm going to try to clean this up a little bit so we can see it. Beautiful. So we're starting off with our mass here on the pink side. So then we need to find out, what are we ending with? So what we're ending with, what we're solving for, is based on where it says how many, and the question is grams of hydrochloric acid. Hydrochloric acid is a different chemical, so this goes on the blue side. And so right here we're going to go ahead and label this as hydrochloric acid on the blue side, and finding grams on the blue side again is actually mass, not particles. There were a couple mistakes up there. We should actually be looking at mass. Mass is grams right here. And then don't forget that in the center, we always have to go through the middle, and going through the middle in 3-step problems, you're always going to go moles to moles, no matter what. Always moles to moles. Smiley faces emojis in the chat if you're feeling more comfortable with this. Looks like most of us got it perfectly the first try, so that's awesome. We should be getting more and more practice with this. Excellent. All right, so do you prefer warm or cool weather? I see so many cold. Why do we prefer cold? And then I see one warm and one in between. When I'm talking warm and cool though, I'm talking like 80 degrees versus 60 degrees. Not like 100 versus 0. All right. So I'm just asking, like, in the reasonable range of weather, do you prefer the cooler side or the warmer side? Yeah. Yeah, I feel like if it's not more than 80, then I think I like a warm day. I think I like a warm day as long as it's not over 80. I don't like hot days. If I had to choose between hot and cold, I would choose cold, but otherwise, warm is fine. All right, looking good. Awesome. Let's go ahead and get started up here.
All right, so I like myself a good Pacific Northwest. I like that cold and rainy. I don't know why, it's crazy. All right, so remember, these Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information or information of others into the chat box for your protection and the protection of others. All right, so let's go ahead and get our attendance. Our attendance is up in the chat box. So if you scroll up, you will see Mrs. Larkin, and then you will see my attendance links, and then obviously the start of the class word. So go ahead and get your attendance in. Remember, you do have the first 15 minutes of class to get that in. After that, you technically do have until midnight tonight. Just make sure you copy the word down, make sure you copy it correctly, and raise your hand. I'm giving everybody 20 seconds to get their attendance in and their hand raised. Go, go, go. You notice that in the chat box, the attendance is going into the chat box one more time in case you did not get it from before. And the beginning of the class word, or start of the class word. All right, so let's go ahead and take a look here. Derek, go ahead and just let us know in the emoji. Maybe you already did. I don't see one, but just in case. Let's see. Kamari, Tim, Anthony, Eric, Annabelle, Jaylyn. All right, where people are moving on me. Sorry about this. All righty. So Stephen, let me know on the in the chat box. Alexis, Tanner, May, Jaylyn, Kamari, and Gabriel, you're good. Derek, let me know in the chat box. Let me know if you are good to go. Kamari, Jaylyn, Tanner, please let me know. Thank you, Derek. Awesome. Mrs. Larkin, if you can get those names, I'll check in with those few people. Excellent. Here we go. So our schedule today, obviously, is looking at can you believe this? This makes me stop. 12 days left. I remember saying 1 out of 60, and we were like, oh, 12 days left. We're almost down to single digits here. So get your stuff in, get your new projects in. I can't tell you enough. You don't want to be that person trying to do it the last minute. No go. So with that, it's Friday, February 12th. Today we're going to talk about our 3-step stoichiometry part 2 and do our 4J notes with that. And so let us move on a little bit. And I'm going to turn it over to Mrs. Larkin because we got some announcements on our project.
Yeah, so this is just a note that we did rearrange the schedule. We decided to let you finish up Unit 4 today, and then we'll go ahead and all of next week we'll work on the project, all right? So the Unit 4 project will be all of next week. You don't have school on Monday, but you'll have Tuesday through Friday to work on it. In class, we'll guide you through what does each slide kind of go over, and then we'll actually give you time to work on those slides each day. So it's a really short project. It's only about 6 slides long. You'll be choosing one of 5 possible reactions. You'll watch a video of that reaction and make some observations about it. Then you'll balance the chemical equation for the reaction, something you should already know how to do. You'll calculate the molar masses, something we've reviewed a few times at this point, and then obviously complete 1-step, 2-step, and 3-step stoic problems. So that's what's coming up. Again, you should be pretty familiar with all this content at this point. We've gotten lots of practice in, but again, you'll need to work on it a little bit more independently next week for that project. Smiley faces, emojis, if that makes sense, everybody. Hopefully that makes you feel more comfortable. You'll have 4 days to make sure that that gets done correctly, and we'll be working on it in class. Awesome. So that should be like 100% for a really short project. You should do great on it. It should help boost your project grade. Cool. Let's go ahead and keep on moving.
So today, what we're going to be talking about, we're going to identify the correct steps needed to complete using the mole roadmap, our famous mole roadmap. Say that 10 times and tell me how you do. Complete a 3-step stoichiometry calculations and then obviously do this through our 4J notes. And I know we all do well on that. So with that being said, I'm going to go ahead and put our notes up into the chat box. With that, there they go. There's Mrs. Larkins, and then mine will come up next. Open those links that are in the chat box, start your quiz, raise your hand. If you are watching the recording, click the grades tab, scroll on down to 4J notes and start your quiz. I'm giving everybody, again, 20 seconds to get that in. 20 seconds, raise your hand. Go, go, go. 10 seconds. All righty, so let's go ahead and check in with, I think Gabriel, Derek, thank you. I see you in the chat box. Bryce, Christopher, Tanner, Kale, Alexis, and then Stephen. Awesome, I see you in the chat box. So Alexis, Kale, Tanner, Christopher, Bryce, and Gabriel, I know you're in the chat box too, so you're good. Bryce, 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 Christopher, 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 Tanner, 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 Kale, Kale, Kale. You are my last 3. Please raise your hand. Please raise your hand. Thank you, Tanner. Excellent. Thank you, Christopher. So Bryce, 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 and Bryce. Excellent job. I think we have, oh, Kale. Kale, come on. You're my last friend. Come on, Kale. All right, Kale. I will be checking in with you. Let's move on.
All right, so let's go ahead and take a look at Avogadro's number today. So this is just a quick reminder. Sorry, you got everyone, right? Mrs. Spilvet, I can lower those hands? Okay. We already learned how to go kind of from grams to grams yesterday, but today we're going to be throwing in some particles. So particles means that I need to go back to Avogadro's number and make conversion ratios with Avogadro's number. Now remember, anytime you have 2 things equal to each other, like 1 mole equal to 6.02 times 10 to the 23rd particles, you can always make it into a fraction, which is a conversion ratio. And the reason why is because in reality, conversion ratios actually equal 1. Now, I know that might blow our minds, so let's go ahead and talk a little bit about what I mean. So remember that 1 dozen is the same as, for example, 12 eggs. So if I were to do, let's take a look here. If I do oh, I hate these tools. They are just driving me crazy today. 1 dozen, all right, all divided by 1 dozen. Tell me in the chat box, what would I get? 1 dozen divided by 1 dozen equals what? 1 dozen divided by 1 dozen equals what? Thank you, Annabelle. Thank you, Gabriel. 1 dozen divided by 1 dozen, yeah, it just equals 1. So that makes a lot of sense. But here's the deal. Again, we literally just said that 1 dozen is the same as 12 eggs. So instead of having 1 dozen here, I can actually substitute in 12 eggs. So let's go ahead and try that. I'm going to sub in here 12 eggs. Oh my gosh, tools. Whew, I gotta breathe. All right, 12 eggs right here. Okay. Now again, this might not seem like it equals 1 because you can see a 1 and a 12 here, but remember that units matter. So 1 dozen is actually the same thing as 12 eggs. And if you have 1 dozen and 12 eggs over each other, that actually still does divide out and equal 1. Smiley faces in the chat box if that's beginning to make sense. So I know that mathematically you're looking at it and you're like, I swear that equals 112. It doesn't though. The units make a difference. 1 dozen over 12 eggs is the same as saying 1 dozen over 1 dozen, which still equals 1. So that means I can throw this conversion ratio into any problem, and it will never change the actual amount of stuff. It just changes my units into the units I want. All right? It never changes the actual physical amount of stuff, though. So in the same way, physically, 1 mole and 6.02 times 10 to the 23rd particles are identical. They are physically the same. So I can put them over each other, throw them into an equation, in order to convert units without changing the actual amount of stuff. So let's go ahead and try that out here. So Avogadro's number is always talking about a single mole. So what should I put next to moles here? What should I put next to moles here in my fraction here? Avogadro's number is always talking about how many moles. Take a look at our equal sign here. Yeah, it's always equal to 1. So 1 mole, I'm going to plug that in on top and on bottom down here. And how many particles are always in 1 mole? Always in Avogadro's number. How many particles are always in Avogadro's number? A big number. Don't be lazy, Gabriel. Actually try it out. Yeah, 6.02 times 10 to the 23rd. I'm going to write it in calculator form, 6.02 E23. You will need to be able to use your calculator today. I am not giving you the answers to the problems today. There are 2 problems. We will set them up, we'll work on them together, but the final calculation you have to do on your own, which means you have to know how to use your calculator. So make sure you're practicing, make sure you have Google Calculator open, that way you're ready to do that. Okay, now again, I can switch these positions and it still equals 1. Again, 1 mole and 6.02 times 10 to the 23rd particles are identical. They still are a conversion ratio. They still equal 1. This one down here still equals 1 because, for example, I can switch 1 dozen and 12 eggs up here. And again, those are still the same thing. I'm still dividing 2 of the same thing. So just a reminder, conversion ratios always equal 1. All right, so we're going to be using that today. Again, make sure that you have your calculator ready.
So let's go ahead and do a little review of the mole roadmap. This is something that we should probably be very, very familiar with because we've been working with it probably for the past week. For the same chemical, you need to know if obviously Avogadro's number is used to convert between particles and moles. We just kind of did a little brainstorm on that, so that just gives you a little background on that one. Molar mass, on the other hand, from the periodic table is used to convert between grams and moles. Okay, grams and moles, this is particles and moles, so just make sure you kind of decipher for that. But the only way to convert to a different chemical is by using that magic mole ratio, that mole to mole ratio from the balanced chemical equation. So whenever you have to look, whenever you're switching into a new substance or a new chemical, you go to that mole to mole ratio, okay? That magic mole ratio right here. All right, that's important to know that before you go into that new chemical. All right, go ahead and give me a happy face, sad face, or a medium face if you understand this. Again, this is a review. We've been working with this mole map all week, so this should be still kind of an understanding. Good. I'm seeing, I need to see more people up there, so I need to still see Gabriel, Bryce, put your answers in. Miles, Tim, Christopher, Monty, Tanner, Jaden, Kale, Patrick, Stephen. Stephen, I know you can't do that. Let us know in the chat box. Eric, Adriana. Yeah, okay, perfect. Now that we're getting more people, nice, Gabriel, I like that cheese. Excellent. Again, we'll be working with this today, but we really want you to make sure that you understand this mold roadmap because this is the key to helping you out through these stoichiometry problems. All right, let's go ahead and move on.
All right, everybody. So, sorry, just want to say. Okay, so let's go ahead and take a look at this question. How many molecules of iron oxide, Fe2O3, can be formed if you have 2.5 times 10 to the 23rd atoms of iron? So go ahead, you have your whiteboard tools, point for me on the board. What are we starting with? What do I already have a number for? What do I already have a number for? I see 3 people up on the board, 4 people, 5 people. There we go. Get your arrows up on the board. Again, you need to be able to calculate this on your own today. So practice, practice, practice. Yes, we know that we have this many atoms of iron. Iron's going to be our starting side in pink. Point for me on the pink side of the diagram down here then. Where do you see atoms? Where do you see atoms? Yes, atoms falls under particles. Now remember that right here, all right, let me pause those tools for a moment. This is important to understand. Remember that iron is a single element, All right, it's not bonded to anything. That's why these are atoms. Smiley faces if that makes sense. Particles of iron are called atoms. Particles of a single element are called atoms. Smiley faces if that makes sense. Cool beans. All right, now point for me on the board. What am I solving for in my question? So point up here. What am I solving for in my question? How many what? How many what? Yes, I'm solving for molecules of iron oxide, so that's going to be my blue side. So I'll label my blue side Fe2O3 and point for me, where do you see molecules on the blue side? Where do you see molecules on the blue side? Yes, molecules are also a type of particle. This time, though, they are made up of more than one element. So it's got 2 irons, 3 oxygens, so that's why it's called a molecule. Particles of iron oxide are called molecules because they're made up of more than one element. Now point for me, what are the middle steps? What are the middle steps? Yes, for three-step stoichiometry problems, you should notice at this point that the middle steps are always identical. You always need to first convert to moles of your known to moles of your unknown. Moles of what you start with to moles of what you end with. We're going to send out attendance one more time, and then we will be deleting it from the chat. All right, so let's go ahead and start off with what we know. We know that we have 2.5 times 10 to the 23rd atoms of iron. I'm going to label that as, I'm putting it in calculator form, so 2.5 E25, E23. Putting it all over what in order to turn it into a fraction? Putting it all over what to turn it into a fraction? Yep, we're going to put it all over the number 1. Beautiful. In the next step, I want to get rid of atoms of iron, so where does it need to go? In the next step, I want to get rid of atoms of iron, so where does it need to go? Yes, always, 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 we put it on the opposite side of the fraction, which in this case would be the bottom of the fraction. So atoms of iron on the bottom. Now, I first need to convert into what units? All right, tell me the units and the chemical. It should still be the same chemical. We always have to get to what units of our starting chemical. So tell me units and chemical, units and chemical. I'm literally pointing to it up on the board. Literally pointing to it up on the board. So grab, well, there's 2 arrows. There we go. There we go. I see Camilla, I see Shelbs. Yes, we always have to get to moles. And the unit and it's the same chemical, so it's going to be moles of iron. We always have to go moles to moles, specifically starting off with moles of what we have, which is iron. Cool, so taking a look here, what do I need to use to go from atoms to moles? Remember, atoms are a type of particle, and we literally just learned a way to convert this. So whose number do I have to use to go from atoms to moles? Whose number do I have to use to go from atoms to moles? Avocados. Tell me in the chat. It literally says it on the board. Again, you need to know how to use this roadmap. Tell me in the chat box, whose number do we have to use to go from atoms to moles? Yeah, we have to use Avogadro's number. So I'll go ahead and I'll label this up here. So we're going to use Avogadro's number for our first conversion, which I also have conveniently listed here for you. So again, Avogadro's number is always talking about how many moles. Take a look here. How many moles are in Avogadro's number? Again, it's always a single mole. Single mole means what? Single mole means what? Yeah, it's always going to be 1. Perfect for Avogadro's number. And then how many atoms are always in Avogadro's number? Again, atoms could also mean particles. Atoms are a type of particle. How many atoms are always in Avogadro's number? Thank you. I see Shelbs. Let's get some more participation. Let's see, people I haven't heard from in a while. Bryce. Let's see here. Jade Lynn. Miles, Timothy, Christopher. Tell me in the chat, what is Avogadro's number? Yeah, it's listed right there for us. That's easy peasy. It's going to be 6.02 times 10 to the 23rd power. I'm going to write it as 6.02 E23. Perfect. Okay, so that looks great. So we've gotten rid of atoms of iron. I'm currently at moles of iron. Is that what I'm solving for? Take a look up here. Am I solving for moles of iron? Read carefully. Am I solving for moles of iron? This literally says molecules of iron oxide. So no, I'm not where I need to be yet. So let's keep on moving. So moles of iron's on the top. I'm going to put it on the bottom to divide it out. All right. And on top, now I can turn into my new chemical. Take a look at our roadmap down here. What is the new chemical and what units must that new chemical be in? We always have to go moles to what unit, and again, give me the new chemical. Don't give me Y, give me what the new chemical actually is. Awesome. Shelves, you have the chemical, but make sure you get me the units too. I see Camilla. Let's get more people in the chat. Thank you. Yes, thank you, Annabelle. Let's get Monty and Anthony and Christopher and Aria, Ame in the chat, Tanner, Jada and Kale, Patrick, Angelo. Let's see here. It is a compound, yeah, but it's moles, so we're not talking about molecules. We're just talking about moles. Yeah, please don't just copy people, because I know you're copying if everybody has the wrong answer. Yeah, so it's going to be moles. So taking a look here, we're going to moles of iron oxide. Oh, sorry, I want to make that a different color. So here we go. Oh my goodness. Come on, tools. Here we go. So moles of iron oxide, Fe2O3. So now we're at our new chemical. Now again, how do I get to what conversion do I need to use here? Take a look at our diagram right here. I need to use what to get to that conversion, to use that conversion. I need to use what? Take a look up here. Read it, read it. What gets me moles to moles? I need to look at the what. Thank you, Annabelle. Yeah, we need the magic mole ratio from the chemical equation. So taking a look at our chemical equation, what is the coefficient of iron oxide in our chemical equation? What is our coefficient of iron oxide in our chemical equation? That'll tell us the number of moles. Thank you. Yes, you can see right here it is 2. And what is the coefficient for iron in our chemical equation? Beautiful. Yes, it is 4 right here. 4. All right, so we've gotten rid of moles of iron. I'm now at moles of iron oxide. Is that what I'm solving for? Take a look at our question. Am I solving for moles of iron oxide? No, moles and molecules are different. I'm not where I need to be yet. We need to keep on going. So here we go, keep on going. I need to get rid of moles of iron oxide. I'm going to put it on the bottom in the next spot. Moles of Fe2O3 on the bottom here. So finally, tell me in the chat, what am I solving for? Read our question. What am I solving for? Again, everyone should know how to do this. You literally just need to read it from the board. So if you are trying to practice with us, which you should be, because you'll need to finish these problems on your own, practice, 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 okay? It's okay if you don't understand everything, but you should practice as much as possible. Okay, so yeah, give me units and chemical, y'all. I need units and chemical. Units and chemical. I have 3 of you with the units and the chemical. Keep on going. What is the chemical? Thank you, Stephen. All right, let's take a look here. Yeah, we're going to molecules of iron oxide. So MlClS. I'm going to abbreviate it just because I don't want to have to write it all out on the board. Fe2O3. Okay, so molecules of iron oxide on the top. Now, again, this middle conversion we got from the chemical equation, right? That's where we always get that middle step from. But this step right here, again, we need to go from moles to molecules. Molecules are a type of particle. Anytime we're talking about particles, whose number do I need to use? Again, take a look down here. Whose number do I have to use for this conversion? Anytime I'm talking about particles or molecules or atoms, I love all the spellings. Yes, it's going to be Avogadro's number. So again, we're going to use Avogadro's number here. Let's go ahead and take a look here. So what goes next to molecules, which are a type of particle, and Avogadro's number? Again, take a look down here. What goes next to molecules or particles? Thank you, Gabriel. Keep on going in the chat. What goes next to particles or molecules? Thank you, Annabelle. Thank you, Shelves. I see Anthony. I see Camilla. Yeah, exactly. So it's going to be 6.02 E23. Sorry, I want that a different color. There we go. So this goes up here. Perfect. And then taking a look here, Avogadro's number is always talking about how many moles. How many moles are always in Avogadro's number? You guys are messing me up now. Yes, always talking about a single mole, so 1. All right, so we got rid of moles of iron oxide. Now we are left with molecules of iron oxide. That's exactly what we want. Now, you might be looking at this and you're like, oh my gosh, Mrs. Larkin, I don't want to plug that into my calculator. And I'm also like, oh my gosh, guys, I don't want to plug this into my calculator. So there's actually a trick right here, which is super nice. Because remember, anytime we have something that's on the top and the bottom, we can divide it out. Now, we've analyzed all the units, but there are actually some numbers that happen both on the top and the bottom. So tell me in the chat box, what number do you see that happens both on the top and the bottom that is not a number 1? I don't care about the ones, okay? What number do you see here that occurs both on the top and the bottom? Take a look at these different numbers. Which one occurs both on the top and the bottom of these fractions? Yes, I see Stephen. I see Annabelle. Yes, what number is happening twice? Once on the top, once on the bottom. Look at the board. Which one do you see happening twice? Thank you, Anthony. Let's go in the chat. Which one do you see happening twice? Look at the numbers. We already looked at units, so now we're just looking at numbers. Yeah, we can actually see 6.02 times 10 to the 23rd on the top here and on the bottom here. So what do you think I can do to it? Tell me in the chat. What do you think I can do to it? Get rid of it. Cross it out. Yes, they cancel, they divide out. So I'm going to actually get rid of this one and get rid of this one. And now look at how much easier that looks. Smiley faces, emojis in the chat box if that makes sense to you. Again, we could just get rid of them because, again, it's on the top, it's on the bottom. Get rid of it. Excellent. I know, it makes me really happy. All right, so on the top now, I'm left with 2.5 times 1 times 2. Oh, sorry, not 2.5. 2.5 times 10 to the 23rd. Whew. And on the bottom, I am left with 1 times 4 times 1. Let's go ahead and start with the bottom. What do we get on the bottom? 1 times 4 times 1 equals 4. Yeah, Shelbs, you don't have to get rid of it in real life. It's just that you can. I'm just letting you know that you can to make your life easier. So again, 1 times 4 times 1, what do I get? I see Gabriel, I see Camilla. Let's get Adriana. Let's get Taylor. Let's get Canyon, Michael participating in the chat, Patrick and Kale and Jaden and Tanner. What is 1 times 4 times 1? Yeah, perfect. It just equals 4. Now let's go ahead and do the top together. I'm going to go ahead and share my screen with you so you can see what this looks like. All right, again, highly recommend that you just Google the word calculator. All right, so we've got 2.5 times 10. So I'm going to use the EXP button to the 23rd times, what was it, 1 times 2? Times 2 times 1? Times 2 times 1. All right, what do we get on the top? What do we get on the top? Go, go, go. Tell me in the chat. Just Google the word calculator, Gabriel. You have to be able to do the final calculation on your own. Everybody, 100% of you must have your calculators out or have Googled the word calculator. Thank you. I see Camilla. Camilla, I see Anthony. Let's go, let's go. Grab your calculators, practice using them. You have to do the final calculation on your own. So if you don't have your calculator or you don't know how to use it, you will not be able to do your notes today. That's why I want us to practice right now. I want to give you all the tools to be successful, but you got to meet me halfway. I'm giving you so much right now, but you got to meet me halfway. All right, there we go. Perfect. Yeah, awesome. So you should be getting 5. This E plus means times 10 to the and 23. So let's go ahead and plug that into our notes here. All right, so taking a look here on top, I should be getting 5 E23, 5 times 10 to the 23rd. Okay, so that being said, this is going to be the final calculation that you have to do on your own. Do not put answers in the chat box. And I do want to mention that your units are going to be molecules, right? Take a look up here. Your units will be molecules of iron oxide. They will not be atoms. Again, atoms are only if you're talking about a single element. We are not talking about a single element, we're talking about a compound. Iron and oxygen bonded together, so these are molecules. All right, so here we go. If you need to check your answers, we will be in the Q&A area, and Mrs. Sepulveda will wrap up our time here.
So this was it's just much nicer printed out for you. So again, What do you have here? This is the final calculation that you will have to do. Again, no answers in the chat box. You could check in with us in the Q&A section. We'd be happy to do that. This is the answer to number 1. So this is the answer to number 1. Make sure you're getting molecules of iron oxide, That is your unit. So again, I'll give you 20, or I'll give you 30 seconds. Okay, 30 seconds. Go, go, go. The Q&A if you're unsure. All right, so let's go ahead and take a look here. Thank you, Stephen. I see you in the chat box. So Gabriel, I do see you in the chat box, so you're good. Bryce, Christopher, Anthony, Tanner, Jaden, Kale, Alexis. I know Shelbs, you're working. And Stephen, you're in the chat box. Good, excellent. Tim, Derek, I don't see you in the chat box, but let me know. Eric, Stephen, you're good. Shelbs, Alexis, Kale, Anthony, Christopher, and Bryce. Thank you, Kale. I see you popping up. Thank you, Bryce. Just a few more people. I know this is it's a difficult one. Shelbs, Eric, go ahead and thank you, Eric. Anthony and Alexis, you're my last two, Anthony and Alexis. Thank you, Anthony. Alexis, last call. Let's get 100% here. Last call, Alexis. Yes, nice job. High five, everybody. Let's move on to the next one. Woo, woo.
All right. Ame, yeah, so for your project, if for some reason it's not letting you submit it, just email us the shareable link. Let us know if you need help figuring out how to do that, okay? But just go to share at the bottom, make sure anyone can access, and then copy that shareable link for us, okay? Perfect. Thank you. Anthony, I don't know if I saw yours. I was trying to respond to everybody. Oh no, I did respond. Yeah, you're good. You're good, Anthony. Awesome. Let's go ahead and go through this. So, how many grams of oxygen do you need to form 7.8 times 10 to the 23rd molecules of water? Point for me on the board. What are we starting with? What do I already have a number for? What is my known? What is my known? Beautiful. Yes, we have a number right here. This is our number. So this is applying to water, H2O. So I'll make the pink side water. And tell me in the graph, where do you see molecules of water? Where do you see molecules, molecules, molecules? There we go. Let's get some more people up there. Where do we see molecules on the pink side? Molecules on the pink side. Perfect. Awesome. So we're going to go down here. That looks great. Now go ahead, point back up for me in the question. What am I solving for? This is the same thought process annotation you should always go through yourself when you're doing a problem. Yeah, so this is our question right here, grams of oxygen. So I'm going to make the other side blue, O2, okay? And point for me on the blue side, where do you see grams, 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 grams on the blue side? Grams on the blue side. Blue side, blue, 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 blue. Yeah, don't move purple, you're good. Blue side. Yeah, here we go. We see grams right here. And what is always the middle steps for three-step Stoic problems? What is always the middle steps? Yep, to get from one side to the other, you always have to go through the center, moles to moles. Let's go ahead and rock this one out. So I'm going to start with what I know, which is 7.8. E23 molecules of H2O. Turn it into a fraction by putting it over what? Put it over what? Thanks, I see you, Jade Lynn. I see Gabriel. I see Camilla. Let's get some more people. Put it over what? Everybody should know this. This is the easiest question of the process. Yeah, put it over 1. Good. Now, in the next step, I want to get rid of molecules of H2O. Second easiest question, so where should I put it? Top or bottom to get rid of it? Everybody should know the answer to this by now. We've done this a bajillion times now. Yeah, molecules of H2O, debajo on the bottom. There we go. Now, again, I'm trying to change this into what units for H2O. Give me the units, give me the chemical. Should be the same chemical on the pink side, but now we're turning it into one unit. What units? Again, the key to the mind map is we always get to what units. Always get to what units. Double check that, Anthony. I see Camilla's got it. Let's go in the chat. I'm pointing at it on the board. We're getting to what units? Give me the units and give me what chemical is still the pink side. Yes, there we go. We are always, every single time have to get to moles, and we have to get to moles of what we're starting with. So moles of water. There we go. Good correction, Anthony. Yeah, so moles of H2O. Perfect. All right, so I've gotten rid of molecules of H2O. I'm at moles of H2O. Now let's go ahead and fill this in. So remind me again, how do I get from molecules to moles? What do I need to use to get from molecules to moles? Molecules are a particle. Particles mean I'm always using what? What conversion do I use? If you need help, look at my arrow on the board where I am pointing it out to you very obviously. We always need to use what to get from molecules to moles? Yeah, we always need to use Avogadro's numbers. So taking a look here, I'm going to go ahead and label this as Avogadro's. How many moles are an Avogadro's number? Again, mole, it's always referring to a single mole. So what should I put next to moles? Yeah, exactly. So 1, perfect. And what should I put next to molecules? Again, molecules are the actual particles. What goes next to particles for Avogadro's number? Avogadro's number. We should have this number pretty much memorized by now. There we go. I see Shelves, I see Camilla, I see Anthony. There we go. Yes. 6.02 times 10 to the 23rd in calculator form, 6.02 E23. There we go. Let's keep on taking a look here. So I'm left with moles of H2O right now. Is that what I'm solving for? Read the question. Am I solving for moles of H2O? No. So we need to keep going. Let's keep on going. So moles of H2O is on the top, and the next step I'm going to put it on the bottom to divide it out. And taking a look here, I can now convert into the new chemical. So give me what is the new chemical with its units. We always have to go moles to what of the new chemical. Give me units, give me chemical. Units and chemical. You've got the chemical, Gabriel, but give me units. I see Camilla, I see Anthony in the chat. Again, it's all on the board for you. I try to make it super obvious. So we're just reading from the board together, making sure we're working on this thinking process together. Yeah, Shelves, I would definitely use Google Calculator if your calculator's not working for you with scientific notation, for sure. All right, perfect. So yes, we are going over to the new chemical, which is now oxygen. And again, you have to go moles to moles. So it's going to be moles of O2. Now, how do I get the mole to mole ratio? I need to go to my what? To get the mole to mole ratio, I need what? Yes, the chemical equation. Let's take a look here. How many moles of O2 are in the chemical equation? How many moles of O2 are in the chemical equation? Beautiful. Yes, there's 1. And how many moles of H2O are in the chemical equation? Excellent. Yep, there are 2. Beautiful. So I have now gotten rid of moles of H2O. I'm left with moles of O2. Is that what I'm solving for? Am I solving for moles of O2? No. Let's keep going. Here we go. So to get rid of moles of O2, stick it on the bottom. Moles of O2, that'll divide it out. What am I finally solving for? What goes on top? Again, we're finally to the last step here. What am I solving for? Both units and chemical. Don't forget those units, Gabriel. Units and chemical. Thank you, Shelves. Thank you, Annabelle. I see Camilla. Yeah, exactly. It says it right here, right? It literally, again, says it on the board. I'm not asking you anything that's not already given to you. It's all on the board for you. So yeah, we're solving for grams of O2 on the top here. Now, remind me from yesterday, how do we get from grams and moles? Moles and grams. We need to use the what of oxygen. Again, I'm pointing to it on the board. We need to use the what of oxygen. Yeah, we need to use the molar mass, which has already been provided to you. Look at that. So take a look here. What goes next to grams in the molar mass of oxygen? What goes next to grams in the molar mass of oxygen? Again, work quickly. We're pretty much out of time here, but I need you all participating fast. Yeah, 16. And what goes next to moles? Again, moles has a blank. We're always talking about a single mole here, so it's a 1. Perfect. All right, so we've got this kind of locked in terms of our units. Let's take a look at our numbers here. So on top, we should have 7.8, E23 times 1 times 1 times 16. And on the bottom, we should have 1 times 6.02 E23 times 2 times 1. Tell me in the chat, what do we get on top? What are we getting on top? Again, make sure you know how to use your calculator. Make sure you know how to use scientific notation. This capital E on Google Calculator comes from the EXP button. Gabriel, you're missing scientific notation. There we go. Awesome. I see Jade Lynn. I see Anthony. You don't have to round this part yet. You don't have to round this part yet. Keep on going. Keep on going. Annabelle, you're missing a decimal place. Gabriel, you're missing a decimal place. Thank you, Camilla. Yeah, so taking a look here, again, make sure you know how to use your calculator. You should be getting 1.248 times 10 to the 25th. So let's jump back over to our work right here. So on top, we should have 1.248 E25. Now, what do we get on the bottom? Again, it's going to be 1 times 6.02 E23 times 2 times 1. I'll show that to you up on the board for those of you who need to see it. Tell me in the chat, what do we get on the bottom? Again, this E comes from the EXP button. Make sure you know how to use it. There we go. Perfect. Yes, you should be getting 1.204 times 10 to the 24th. All right, this is really important that the exponent here is different. So make sure you don't mess that up when you do the final calculation, 1.204 E24. So you're going to do top divided by the bottom. For your answer, it needs to be formatted with 2 decimal places. So number, number, dot, number, number. That's what your answer should look like. And again, units here should be grams of O2. Here we go. We'll give you some time to work on this.
Nice and beautiful than before. So again, this is where you're going to be looking right here. You're going to be doing this final calculation right here. Final calculation right here, and your answer will go right here. No answers in the chat box, please, but it will be number, number, decimal point, number, number. Check with us in the Q&A. We're going to give you 30 seconds to go ahead and work on that. 30 seconds. Go, go, go. This is our last problem. Take a look at this. Nice job. I see them coming up in the chat and the Q&A. Excellent job. All right, so Gabriel, Jade Lynn, Christopher, thank you. Let's see, Monty, Aria, May, Camilla, Tanner, Kale, Alexis, Patrick, Shelbs, Eric, and I see Derek in the chat box. Thank you, Gabriel. I see you in the chat box. So Christopher, Monty, May, Camilla, Tanner, Kale, Shelbs, and Kamari. Please raise your hand. Raise your hand. Perfect, Shelbs. That looks good. All right. So last call, Christopher, May, Camilla. Last 3, Christopher, May, Camilla, Camilla, Christopher. Perfect. All right, here we go. So today we talked about identifying the correct steps needed to complete a problem using the mole roadmap. We did that 3-step stoichiometry calculations, and we did this all in our notes.